So looking at the sine rule today, probably look at the cosine rule because it's pretty simple. There are a few challenges in it, but yeah, not relative to a lot of the other content we do, probably on the softer side. So the sine rule works for both right angle triangles and non-right angle triangles. The most common type of triangles we see is with our non-right angle triangles. Okay, so it's very common that we give triangles that do not have a right angle and we ask us to use the sine rule. Now they won't specifically say use the sine rule, they'll just give us a set number of unknowns in a certain organisation. We have to decide whether we're using the sine rule or a different rule. So, first things first is how we label the triangle. C, B and A, doesn't matter which side I call what, I can call them whatever letter I want. I'm just picking those three letters because of the first three in the alphabet. The angle that corresponds with this side, little a, is opposite of it. So that's where I would put capital A. So capitals denote angles, lowercase denotes our sides, which means that this one would be B and this one would be C. So for our sine rule to work, we have, and I'll write it what the sine rule is. So the sine rule is sine A over A equals sine B over B equals sine C over C. Now we don't need all three of those, we really just need two. So this is pretty redundant because again, I can label the sides whatever I want. Happy with that? For this to work, we need two sides and one angle because I need to have one unknown, correct? So I have two sides and one angle, and the angle must be corresponding. So if I've got side A and B, I can't have angle C. Does that make sense? So when I say corresponding, I must have angle A or angle B if I've got these two sides. Does that make sense? Because if I've got A, B and C, well I've still got two unknowns in my equation. Cool? Not the case with our angles though. So I can have angle A, C and side B and still get my answer. How come? Yeah, because of the fact that we know that the angles inside a triangle equal 180. Because I know the angles inside a triangle equal 180, if I have two angles, how many angles do I really have? Three. So if I have two angles, I really have three angles. So I don't need a corresponding side, I just need two angles and a side. Happy with that? If you're not sure about, I guess the part I'm trying to highlight is the word corresponding angle. It must be one of the angles that we have. Because if we know two sides in a triangle, we don't necessarily know the third. If we have two sides in a right angle triangle, what can we use? Starts with P. Pythagoras. We can use Pythagoras, but again, a lot of these are non-right angle triangles. Cool? Awesome. So let's go through some examples and we will see how we go. Now, one of the things that you need to be able to do is seamlessly shift between radians and degrees. So, first thing we're going to do is go to our calculator and we're going to write sine 30. We also need to know our exact values. Sine 30, what do we know sine 30 is equal to? 1 on 2 as per our exact triangles. Check if your calculator is in degrees or radians. What measure is that? That is degrees. So if your answer is 1 on 2, your calculator is in degrees. So check. Wait a second. Once you've done that, I want you to write shift pi on 3. Now, if you can do both of those things in your calculator, change between degrees, you are all good. If you cannot, you need to put your hand up and I will show you. Are you currently in degrees if your hand is up? Are you in degrees? And you can't get to radians? So on your math screen you go shift, I think it's set up. if you can do that, we're all good with the calculator stuff. Now, before I go any further, because I've already had people ask about it, I normally wait to reveal, but this can be represented as A over sine A equals B over sine